So using the formulas that we talked about, we are going to try and answer some of these practice questions. And first we will start with the law of dilution one. So if you dilute 175 milliliters of 1.6 moles per liter solution of lithium chloride to 1 liter, determine the new concentration of the solution. So what this is saying is, in my starting beaker, I had 175 milliliters of a concentration of 1.6 moles per liter solution. So this was essentially my C1 is 1.6 moles per liter. My V1 was 175 milliliters, which is 0.175 liters, right? I had to divide this by 1,000 to get 0.175 liters. So this is what I had in my beaker originally before I diluted. And now we are diluting that to 1 liter. That means my V2 was 1.0 liters, or that's basically 1 liter, right? Because I've added the remaining water. I've added more water so that my new volume is much higher. And so I'm asking you to determine the new concentration. C2 equals question mark, because I don't know what that is. So here we will have to be familiar with the rearranging part of this equation. So we take C1 as 1.6, V1 is 0.175, C2 is, I don't know, I'm going to leave that as C2. Volume is 1. I'm going to write just 1 liter. To solve for C2, we have to divide by whatever is multiplying into it. So we're going to divide both sides by 1, which doesn't really do anything in terms of value. So my answer would just be 0.28 moles per liter. Right, that is my new volume. My new concentration, because I've done 1.6 times 0.175 divided by 1. And I've divided both sides by 1 because that's what's multiplying into my C2. Right, so that's the thing. So you need to make 10 liters of 1.2 moles per liter potassium nitrate. What molarity would the potassium nitrate solution need to be if you were to use only 2.5 liters of it? So what this is saying is, this is my final solution. I have to make this, essentially. You can call that, technically it is the C2V2 because it's after the dilution is done, but it doesn't matter which order you put those in. So we can say that C2 is 1.2 moles per liter, and V2 is 10.0 or 10 liters. If you say C1V1 here, it's not wrong. You will get the same answer, and you will get full marks for that question. So what molarity? So I'm asking you for the concentration. Would potassium nitrate need to be if you were to use only 2.5 liters of it? So volume is now 2.5. So I started off with a 2.5. What concentration do I need to have to get, when I make the volume 10, I want my concentration to be 1.2. So what concentration should I start off with the 2.5 and add water to that? So again, I'm going to do here C1V1 equals C2V2. I'm going to leave C1 blank because I still don't know what that is. V1 is 2.5. C2 is 1.2. V2 is 10, and therefore when I do division, I divide both sides by 2.5 so I can get rid of the 2.5 from the C1. So I want to isolate for C1. So the 2.5 is bothering me because it's multiplying into the C1, so I divided it out to get rid of that. So that will leave me, I believe, with C1 equals 4.8 moles per liter. That is that's the concentration I need to start with to get this diluted solution. There's a typo here. You need to make a 2 liter 0.05 molar NaOH solution for a class. You're just going to add that 2 liters, but I think you can try these on your own. So again, you need to make 5 liters of 0.1 molar. So that is my, this is my V2, this is my C2. I have a 6 molar, so I have C1. So I need to find my new volume of HCl, right? So I need to find V2. And how much water would be 5 liters minus V2, because I need to add this volume, V2 of HCl, right? So, but I need 5 liters in the end. My other volume has to come from the water. So I need to do 5 liters minus whatever HCl I'm adding, and that's how much water I need for my solution. The same thing over here. So this is this is V2, C2. I've given you C1, and you have to calculate V1 and then do 2 minus V1 to get the volume of water you need. So you can try that on your own. If you have any questions, post a comment on the video and we will talk about that. Next, we shall do some concentration questions. So I am going to make some changes. Here we won't be calculating mass percentage. I won't ask you to do that. But everything else I think should be fine. Actually, there's not. I said these are hard questions, but I will expect you to do them for homework. I'm giving you some class time to do this, and then we will talk about them. There will be similar questions will be on your test, so be expecting these things. So I'm given my volume is 1.0 liters. Number of moles is 0.143. Calculate its molarity. So we know that molarity is capital C for molar concentration is the same thing. And we know the formula is number of moles divided by volume. 0.143 divided by 1.0, 0.143 moles per liter. And this formula I got right from the previous page. Not this previous page, this previous page. And then go back. Okay, I got it from here. This formula right there. C equals N over V. Right, so that's where I got that from. Whoops, wrong. I'm in the wrong place. Okay. A 250 milliliter bottle of apple juice contains 35 grams of sugar. Calculate molarity and mass percentage. So you can do this you can do this. So first let's calculate molarity. So molarity is a bit difficult to calculate because my formula is N over V. That's to calculate molarity, right? This is molarity, my capital C, molar concentration. N is difficult to get first. I mean, it's not difficult. So it's not given in the question directly, which is why I have to do my first formula, number of moles equals mass over molar mass. So my mass equals 35 grams. I know molar mass of sugar is 180, I think. Let me just check that. Indeed, it's 180.12. Well, actually, it's 180.18. Whoops. And then I get my number of moles to be 35 divided by 180.18, which is 0.194 moles. So now that I have my moles, I can go put that in, 0.194 moles. And I'm going to divide it by my volume of solution. But remember, this volume has to be in liters. So 250 divided by 1,000 is 0.25, and that's my volume. So I do this divided by 0.25, and my answer is 0.777 moles per liter. So that's my concentration of sugar in apple juice. The mass percentage is a lot easier. I can do either weight per weight or weight per volume. Both are acceptable. You can decide which one to do. since I'm given a volume, I'm just going to do weight per volume. So mass percentage equals 5 grams divided by 250 milliliters times 100%, which equals 2. So let's do 5. Oh, that'll just be 2. So it's 2%, and I have to show that I've done a weight per volume. So I'm going to write 2% in brackets W over V, and that's important to write down. So what does it mean for a solution to be 5% weight per weight? So when I give you 5% weight per weight, this means that I have 5 grams of solute in 100 grams of solution. That's what that means. So the same way 5 ppm would be 5 grams of solute in 1,000,000 grams of solution. And this 5 ppb is the same thing. 5 grams of solute in 1,000,000,000 grams of solution. So that's what it means. That's what you can kind of think of when I say 5 ppm. So you're thinking, okay, 5 grams of solute in 1,000,000 grams of solution. So you have to think that, and that will help you in your other calculations. So there's 5 grams of AU, which is gold, in 10 liters of solution. Calculate ppm and molarity. Oh, I need a periodic table for this. Let's go to P table. Okay, I needed the 196.17, so we'll remember that. 196.97, was it? The molar mass of gold? 97, there we go. Okay, I know that by looking at my periodic table. Okay, 5 grams in 10 liters of solution. Calculate parts per million. So parts per million will have to be 5 grams. So we'll remember ppm equals mass solute divided by mass of solution times 10 to the power of 6. But remember, mass of solution is in milliliters or grams, right? So that's very important. So mass of solute is 5. Mass of solution, for all intents and purposes, gram and milliliter are interchangeable units, which means you can use one or the other. It does not really matter which one you are using, just because the density of water is 1 gram per milliliter, which we're always using water in this course. So yeah, 10 liters of solution. So that is 10 times 1,000 milliliters or grams of solution, and we're going to multiply that by 10 to the power of 6, or 1,000,000. So I know if there's numerators in 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros, which is 500 ppm is my ppm, essentially. So now molarity is going to be calculated by doing, first I have to find number of moles, which is mass divided by molar mass, 5 divided by 196.97. Let's do that calculation. 5 divided by 196.97 is 0.0254 moles. And I do 0.0254 moles divided by 10 liters, which is 0.00254 moles per liter. That is my molarity, or concentration, right? So I've done number of moles divided by volume, and that has given me volume in liters, and that has given me my molar concentration, and that's about that. Last question we'll do is the safe limit for lead in water is 5 ppb. How many grams of lead can there be in a glass of water for it to be safe? I'm assuming we're drinking a tall glass of water, so we'll say 500 milliliters or 0.5 liters, we'll stay in milliliters, is our 1 glass of water. That's a big glass. It's actually slightly more than a pop can, so let's assume we're very thirsty. So 500 milliliters of water is in a glass. The safe limit of lead is 5 ppb. So how many grams? Snooze, I think. How many grams of lead can there be in a glass of water for it to be safe? So the accepted limit is 5 parts per billion. So we're going to say, so if you think about it, we have 500 milliliters of water. So we know that the parts per billion formula is mass of solute divided by mass of solution times 10 to the power of 9. And therefore, we are given our parts per billion to be 5. Mass of solute we have to find, so how many grams of lead, so we're going to leave that as m. Our mass of solution is 0.5, and then we have to multiply this by 10 to the power of 9. So to solve for m, basically, we have to multiply both sides by 0.5 to get rid of the 0.5 at the bottom, right? And then we have to divide by a billion to kind of get that out of the way. So the answer would be 2.5 times 10 to the power of negative 9 grams of lead. And that's a really, really, really small amount of lead. That's basically no lead, essentially. Which is, it's like 0.00000000025 grams of lead, right? So that's an insanely small amount. I'm just realizing that this calculation might be a bit complex for me to ask on a test, so I will not ask it, but it's important to know how to do it. So we will look at this calculation, and basically, yeah, you should know how to do that. It's just weird because we have the 10 to the power 9, and dividing by that's it's not the easiest if you're not familiar with the calculators and stuff, so it won't be on a test. I think you can try these on your own, and you'll just cancel off the mass percentage from this question. Question 6, there's no mass percentage. Everything else you should be fine doing. This is, again, a star question, it's kind of difficult. You can do these ones. This is a star question, kind of difficult, won't be on a test. Everything else is very similar to what we have done, so you can go ahead and try those for homework on your own. I'll see everybody in class.